Hi everyone, Assalamualaikum and good morning. This week we're gonna start with a new topic, which is chemical energetics. Okay, so it will take a 1 week lesson for the chemical energetics. Okay, today Wednesday and the other day is Friday, so I try to finish this topic on by Friday. Okay, so chemical energetics. What you're going to learn in this topic is you're going to learn about the exothermic and endothermic reaction. But actually, you have already familiar with the exothermic and endothermic reaction during your lower form. Okay. The new one is this time you're going to interpret the energy level diagram to show that there is exothermic and endothermic reaction. Okay. During a chemical reaction, there is always an energy change. Energy is given out or taken in. The energy is usually in the form of heat, but some may be in the form of light and sound. So reaction can be divided into two groups, which are exothermic and endothermic reaction. Exothermic reaction give out energy, so there is a temperature rise, and here are three examples. Okay. Example number 1, heating the mixture of iron and sulfur, so they glows red hot. Example number 2, mixing a silver nitrate and sodium chloride solutions give a precipitate, white precipitate of silver chloride, and temperature rise. At the same time, okay, here actually you can feel the container feel warm, okay, using your naked palm. Okay. Next, adding water into a lime. Lime is also known as calcium oxide. Okay. Heat is given out and temperature rise. Okay, temperature rise have been measured using the digital thermometer here. Okay. Next, exothermic reaction. So if you can see on the diagram here, there is a heat release to the surrounding. Okay. Heat release to the surrounding cause the surrounding temperature to rise. So how do you explain that there is a temperature rise? You can detect using a thermometer, or you can feel the container, the wall of the container can feel warm. Okay, all right. So the reaction is like this. Reactants here, okay, release energy. Okay, kat sini release heat energy means it is an exothermic lah. Dia release sama macam diagram dia kata release heat energy kat sini. Dia buang heat energy. Okay, and it form a new product. Okay, other example of exothermic reaction. Okay, reaction between water and acid. A campfire ni combustion lah, combustion. Okay. Rusting is an exothermic. Freezing water into ice. Okay. And nuclear fusion. Nuclear fusion bombardment of nuclear lah. Right. Other example like neutralization of acid and alkali, combustion of fuel. Okay. Combustion of fuel to start heat something of cooking lah. So the more energy they give out is the better. One more thing is a respiration. Respiration is an exothermic reaction. It provides energy to keep your heart and lung working and warm and for warm and movement. Okay. Next. Endothermic reaction. Endothermic reaction takes in energy from their surrounding, and here are the two examples. Okay. When barium hydroxide reacts with ammonium chloride, the temperature falls. There is the temperature decrease. That water under the breaker will freeze. Okay. So maksudnya temperature becomes lower than the room temperature. Okay. Next example is a sherbet. Sherbet ni everyone have experienced this. Okay. So actually when you put a citric acid plus the base sodium hydroxide carbonate, the neutralization that occurs takes in energy. So your tongue becomes cool. Okay. Alright, endothermic reaction. is chemical reaction that absorb heat from the surrounding, okay, cause the temperature to drop and the containers becomes cool. The reaction is like reactant plus energy here means absorb energy and produce a new product. Okay, so nampak kat sini endo absorb, right? Other example of endothermic reaction: evaporation of water, baking of bread, frying egg, and photosynthesis. For the photosynthesis is a process which plants convert carbon dioxide and water into glucose, and it depends on the energy from the sunlight, right? Okay, sebenarnya this is a cooking purpose, macam baking a bread, frying an egg is an endothermic reaction. But to start the fire kat bawah ni, okay, bahan bakar, a combustion of the fire tu sebenarnya adalah exothermic reaction. Okay. Next. Energy level diagram. So from the energy level diagram, you can explain whether the reaction is exothermic or endothermic. Okay, so kita tengok exothermic energy level diagram for exothermic reaction. Okay, so selain you must familiar with the energy level diagram for each reaction, you must also be able to draw the energy level diagram. So first, if you want to draw the energy level diagram, you must draw the vertical line here using a ruler. So tak boleh guna freehand, mesti guna pembaris. And then dia macam lukis graph, they have a y-axis and x-axis here. Okay, ada anak panah di sini. Okay, then the vertical line here labeled as energy. Okay, alright. Horizontal line belah atas ni dekat dengan energy is a reactant. Okay, yang belah bawah ni dia punya produk yang terhasil, and arrow point ke bawah is the energy given out. Okay, ini adalah perkara-perkara yang perlu ada dalam energy level diagram, especially you are instructed to draw the energy level diagram, mesti ada benda-benda ni, wajib tulis. Okay, alright. How about the endothermic reaction? Okay, so sama juga sebenarnya. Okay, dia ada y-axis and axis. Okay, here is the energy, right? Cuma berbeza adalah kedudukan reactant and product. For the endothermic reaction, reactant is lower than the product kat atas, right? So the anak panah yang ke atas indicates that energy is taken in from the surrounding. Okay. If you see exothermic here, the product have lower energy than the reactants, and endothermic here, the product have higher energy than the reactants. Okay. Kena familiar dan kena tahu lukis lah, sebab sometimes in the exam question dia akan suruh awak lukis. Okay, here is the example. They carry out a simple experiment to show that the reaction is exothermic or endothermic. Okay, boleh tengok sama-sama .
When a compound is dissolved in water, it involves exchange of heat. This is known as heat of solution. Some of the compounds dissolve with evolution of heat. This causes increase in temperature of the water. This is known as exothermic dissolution. Some of the compounds require heat for dissolution. This causes lowering of temperature. This is known as endothermic dissolution. We will try out 3 dissolutions and see which of them are exothermic and which are endothermic. We need some water, sodium hydroxide, ammonium nitrate, sodium chloride.
So we have 3 chemical
Note the temperature of the
here.
water.
First,
it is 20 degrees
Celsius. The temperature of the water. So it is 20 degrees C.
Add water to the first beaker
So the first beaker, we are mixing a sodium hydroxide with water.
And then add sodium hydroxide.
Okay. We put in the sodium hydroxide into a water and we stir the mixture.
Stir well. Note the temperature of the solution. The temperature
And then we
is
measure the
about
temperature
48
again. We
degrees.
can see that there's a temperature rise
Now
to
add water
48
to the
degrees
second
C.
beaker and then add
Second
ammonium
beaker is
nitrate
ammonium
and again
nitrate.
check the temperature. The
So you can see
temperature
that the mixture of
is 8
ammonium nitrate
degrees.
with water causes the
Now add
temperature
water to
drops
the
until
third
8
beaker
degrees C.
and then add sodium chloride.
For the sodium chloride reaction with water, there's no significant changes in the temperature, but you can see a slight increase in temperature, about 2 degrees C.
Note the temperature. It is about 22 degrees.
Yes, 22 only.
So we see that the dissolution of sodium hydroxide is highly exothermic. Heat is given out during dissolution. However, dissolution of ammonium nitrate turned out to be endothermic. Heat is required for dissolution. It is taken from water and its surroundings. Both these examples show a large exchange of heat during the dissolution process. On the other hand, in the case of sodium chloride, there is only a small change in temperature, indicating only a minute exchange of heat taking place during dissolution.
So that's all. From the activity, we can explain that reaction is exothermic or endothermic. Cuma contoh-contoh yang saya bagi tadi tu better for you to memorize lah. Okay. Okay, now we go to the bond breaking and bond forming. Okay. Whether a reaction is endothermic or exothermic, it depends on the difference between the energy needed to break the bond and the energy released when the new bond are formed. In a chemical reaction, bond must first be broken, okay, and then new bonds form. And breaking bonds takes in energy, while making bonds releases energy. So kena ingat satu je lah, bond breaking. If you want to break a bond, nak putuskan satu tali, we need some energy. Okay, so energy here means heat energy lah. So bond breaking needs to absorb heat energy, while bond forming, we will release the heat energy. Okay, bond breaking here, you can see that we have a chemical substance here. Okay, a molecule, compound kan, and then dia takes in energy. Okay, heat energy is taken from the surrounding and up. When the bond breaking, the chemical compound form a new formation of product lah. Dia bergabung macam ni, dan bila dah putus, dia jadi single lah. Okay, what happens actually is, more energy is required to break the bonds than that gain from making the new bonds. The change in energy is positive since the product have more energy than the reactants. Okay, the symbol delta H, ini kita akan jumpa nanti, is used to show the change of heat energy lah. Okay, H means heat energy, delta tu adalah change. Okay, H is the symbol for enthalpy, which is measure of the total heat of reaction of a chemical reaction. Therefore, an endothermic reaction has a positive delta H value. So endothermic reaction, dia punya signage adalah positif. Okay. Example, bond breaking, heating an ammonia. Ammonia, the chemical compound, the chemical formula is NH3. If you heat ammonia strongly, it breaks down to nitrogen and hydrogen gas. Okay. First, the bond in ammonia must be broken, so energy must be taken in for you. For this, okay. Heating tu kita yang supply lah, sama ada kita panaskan dia. Right? You can see here that this is how we break the bond between nitrogen and hydrogen. Okay, yang warna merah ni. Okay, next, And after that, the new bond will form. Okay, hydrogen atoms bond together, so the nitrogen atoms. This releases heat energy. Okay, the formation of hydrogen and nitrogen gas needs to release heat energy. Okay, dia tak break bond dah, dia nak forming a new bond. So release energy lah kat sini. Kat sini dia absorb. So this is endothermic reaction, and formation of the product is an exothermic reaction. Okay, this time, okay, untuk reaction heating of ammonia, the energy taken in for step 1 is greater than the energy given out in the step 2. So when the energy taken in is greater than energy taken out, we can say that this is an endothermic reaction. Okay. Siapa yang dominan, so kita akan expect dia adalah reaction yang itulah. Bond forming. Okay. So tadi tu lah kan, daripada dia kecil-kecil and then they form a new bond kat sini, so dia bercantum. Okay, so heat energy here is released to the surrounding. Kita tak perlukan tenaga untuk break the bond because we want to form a new bond, so kita release heat lah. Okay, so more energy is released when new bonds are formed than energy required to break the bonds in the reactant. The change in energy is negative since the product have less energy than the reactants. Negative for exothermic. Okay, therefore exothermic reaction has a negative delta H value. Okay, bond forming of hydrogen chloride. Reaction between hydrogen. Sorry, ini bukan nitrogen typo, sepatutnya chlorine Cl2. Okay, hydrogen react with Cl2 to produce hydrogen chloride. Okay, what happened here? Okay, first the bond in the hydrogen and chlorine molecules must be broken. So for the reactants, energy will be taken in lah untuk break the bond. Okay. After that, a new bond formed between hydrogen and chlorine, so heat is released. Okay. Chlorine combine with the hydrogen to form hydrogen chloride. Okay. This time, the energy taken in first step, for step 1 is less than energy given out in step 2. So this reaction give out energy. So kita nak kata energy release is greater than energy absorbed. Okay, so overall reaction is an exothermic. Right, if the energy taken in to break bond is less than energy release is in making bond, the reaction is exothermic lah. Dalam bahasa lainnya, energy release is greater than energy absorbed, so there is an exothermic reaction. Okay, right. Endo so means en and enter lah, enter heat, enter taken in, absorb. Exo means exit, so heat release, heat keluar, release, right? So ingat yang tu sajalah, right? So quick review. 2 steps must take place to go from reactant to product. So what are they? Okay. From reactant to products, it is a bond breaking and bond forming. For bond breaking for the product, for the reactants, and bond forming for the product. So bond breaking basically is an endothermic reaction because we need to absorb heat energy in order to break the bonds. And to form a new product, it is an exothermic reaction. So we release heat energy. Okay, number 2, some reactions are endothermic. Explain why using the ideas of bond breaking and bond making. So bila satu reaction tu kita decide dia adalah endothermic because the energy needed or energy absorbed is greater than the energy release. Okay, kalau kita buat penyeraan, energy to break the bond is greater than energy to making a bond. So there's an endothermic reaction and the value is a positive. Okay, energy change is a positive. Alright. So that's all for today. We will continue next. Next kita akan calculate the energy changes lah. Okay. Alright. So thank you. Assalamualaikum.